Okay. The second part here we're going to take a look at is the rotor. So, the rotor, remember, is just a big winding that's a constant winding, and it goes from one end and it wraps round and around and around and around and around and around, and it comes out the other, right? Now, the each end is going to be attached to the slip rings here. So, if we look at it and said, this one here is this slip ring here, and this one here is this slip ring here, we want one full continuous winding in there. So, again, we're going to go for continuity and test it here. Test our meter. Good tone. So there should be continuity between the two slip rings, from one slip ring to the other. Again, there we go, telling us our rotor winding is good, it's not broken anywhere. We also want to check it for insulation to make sure it's not short to ground. So the ground, remember, is going to be the rotor shaft itself. So we're not shorted out to the rotor shaft, no, and we're not shorted out to these poles here. So no connection there. So open circuit there. That's what we want. So we want closed circuit from one winding to the other, and then open circuit everywhere else. Open circuit here, and open circuit on the shaft itself. Okay. So remember, inside here, we've just this big winding here we can see here, just wrapped around and around and around. And again, it's that enameled wire, so it's insulated from itself, with that coating on the wire itself, so it can't actually short itself out. And that's basically what our rotor does. Now remember, we said that we have a regulator here, and this was our regulator pack. Remember this? And this was going to control the voltage and current going through the actual stator here. And here's my two brushes here. So we can see the brushes are spring loaded inside there. If we take a look there, as you can see the spring, and they will keep those brushes pushed out against those slip rings here to make sure they're always in contact with it. So what happens is we push them in contact with the actual slip rings here, and now we have a circuit, because we're going to push a plus through one and give an earth to the other side, and we're going to control the amount of current going through this winding here, which is inside here, which is going to give us, remember, once a current starts to flow in there, we get a magnetic field created. And how strong it's going to be, one of the factors is we are going to control the amount of current that's going through. So if we wanted to have a lot of current produced at a low RPM, we could just up the amount of current flowing through this winding. If, on the other hand, we had a high RPM and we had very little on, we don't want to produce that much, we can turn the current right down. So even though it's spinning away really, really fast, we're not actually producing that much of a current out of it. And if I can control the current by controlling the input to the rotor, I can then control what is created in the stator windings up here. So once I have control of the rotor, I control the output. I control the output by controlling the input by controlling the rotor. Okay, now let's take a look. Because we said this is going to be rotating, and we said it's a north-south, north-south, north-south here, you've seen in your notes, we're going to get a rotating magnetic field, which is going to produce a waveform very similar to this, which is an alternating current, an AC current. Now, in most of our electrics and cars, we need it DC, direct current, so a constant feed, unwavering, up and down. This is what this little device does here for me. This is our rectifier pack. So we've already had a look briefly at these when we were stripping. We know we have 3 diodes this side, and we have 3 diodes, if we look and see in there, the other side. So 1, 2, 3. We have got 1 here, 2 here, and 3 here, right? So that's 6 diodes in total. 3 of them are going to be connected to our positive side, and 3 of them connected to our earth side. So 3 power diodes and 3 earth diodes. So a diode, like any other test, is tested the way we tested the last diodes. So if we look at our meter, I can get a diode test up here, and we can see it on the top up here. That's our symbol up here for diode testing, and test it like we would an ordinary diode. Remember, a diode is a one-way valve for current. So let's see. This is the tip of one here, and this is here. No, just been lucky, or maybe I knew. Remember, I'm getting a reading this way. If I swap over, I shouldn't get a reading this way. So it should only read in one direction. Right? So I'll go again. I shouldn't have a reading this way. I should have a reading that way. So that diode is conducting in that direction, and I don't want it conducting in the other direction. Yep, so that's okay. And the last one is here. So it's conducting in this direction, which is good. I'll swap my leads over. It should be not conducting in this direction, which it isn't. So those 3 diodes on this plate here, this one, this one, this one, are all good. I've tested them. They're only conducting in one way. Now, if you're doing this in question, what I normally do is stick just a little dab on them to let myself, or remind myself that I've done them, which leaves me then with these diodes in here. So I have one here on this side, and if I look, I can just about barely see in here. I'm going to go this way. So conducting in that way, and we're on this diode inside here, not one of the ones that I've marked. And we go back again, just make sure. Yeah, conducting that way. So that one's okay. Swap the leads over. So, ooh, look at that. That one does conduct in both ways. That's very impressive. It's always good to find something like that as well, because you can prove it actually does happen. So a diode that is going to conduct in both ways. Let's check again here. Yeah, around there. Oui. Sorry, removed. So that's conducting that way. Check it again just to make sure we didn't do anything funny. No, it's not. Okay, so my meter setup was wrong. So always good to check yourself every time this meter turns automatically off, it resets. So that one is good. We're going to move on again to this one in here, which is in there. So no connection that way. Swap the polarity. We should be conducting this way, which we are. And the last one then is all the way over here. So should be conducting this way. And when we swap the polarity, it shouldn't allow anything to conduct in the opposite polarity. Okay, so again, we're done there now. Okay, so that's a simple test for your rectifier kit. So we've tested our stator windings, which found them to good. We've tested our rotor and our slip rings, we've found them to good. We've tested our diodes. The last little bit is in here for strict testing of a rectifier pack. Now, we're just going to zone in here purposely or specifically on these brushes. So when the brushes come new, they will be of a specific length. with a piece of cord coming out of them. And we're going to solder this onto here. So you can see in here, that piece of cord that's moving there is soldered onto this piece here. So we want to make sure, and inside them there'll be like pieces of copper inside this carbon here, so impregnated carbon. So let's see, we just want to check again for continuity. So touch off one end of the brush and go right to the bottom end. Yeah, good continuity in that brush. And then on this brush over here, we'll take a look. And good continuity on that brush. And then we shouldn't have any continuity between them. So again, we've gone from brush to brush there, and there should be an open circuit there. Okay, now the other thing we need to look at on the brushes is the length of these brushes, right? How long they are. Each one will come with a specific length in it when it's new. So as they wear away, they wear down and get smaller and smaller and smaller. Now the spring, we said, keeps them in contact with the slip ring at all time, but you would visibly be able to see, and even if you look at these two, we can see they are different lengths. So this one has more wear on it, you can see it there, than the back one does. So that's a lot more on it than this one here. So they wear at different speeds as well. So they're quite easy to change. If I needed to, I could just unbraze or unsolder this wire off the end of it here. So pop the brush in and solder the wire back on. Again, we're ready to go. Regulator pack renewed, or brushes renewed and ready to go. And we are going to check the regulator on these on the car with live testing. Now the regulator, remember, controls power output of the alternator by controlling power input to the alternator rotor windings, right? That's what it's going to do for me. The rectifier pack is going to turn AC into DC, right? So from our regulator here, remember we said we have 3 negative and then 3 positive diodes. What we want to do for each one of these windings is connect them into this rectifier pack. So we're going to take one from here, because these are connected here. These are connected here. And this one is connected here. We're just going to loop them across like this so we know it's not connected. So this one here, I'm going to bring this straight down here, and we're going to connect to that. This one here, I'm going to bring up. I'm just going to show it is not connected. And we're going to bring it to this one here. And this one here, we're going to bring it up and out to here. So out each one of these windings here is going to come an AC current. So let's take this one up here. If this winding produces an AC, it comes out here and it will go out in that direction, heading to the battery positive. It can't come back because the diode won't let it flow in that direction, and it won't go that way because it can't let this diode won't let it flow in this direction. So the only way it can go is push it back that way. Same for each one of these diodes. As they get connected, the winding is connected to it, it pushes it in a direction, keeps it flowing in one direction only. It won't let it come back and it won't let it go to earth. It's going to push it through to that plus. So if we bring them all, and bring them on and brought them to a plus up here. These ones, remember, for it to be a DC current, it has to get back to where it came from. So if this winding created the current and it sent it out through this part of the rectifier pack and it went off, and it goes through the plus of the battery, goes through the battery, it has to come back from the earth back to where it got created. So it'll choose whichever the shortest path is back to that one there. So it could come through this one, back through here then, through this diode, out to here, and it's back to where it came from. So it's a constant switching on and off through the rotating magnetic field of which winding is going to output. And remember, once it outputs, it has to get that current back in through one way or the other, through one of the other windings, to get it back to where it came from. So it's a constant cycle of pushing and pushing and pushing. The rectifier pack transforms it from AC to DC. So we'll not let it go back to AC. Now, keep it in mind, there will be a certain amount of AC, a very, very small amount of AC in it, but not that we have to worry about it too much at this stage in the game. The diodes, on the other hand, and the reason why we check the diodes is to make sure that there is only one way. Once those connections are made here, 1, 2, and 3, there is only one way that the current can go. So it forces it out to positive and lets the current back in to get back to where it created from, because remember, every DC current has to get back to where it got created from. So once it pushes it out that way, it won't let it go that way. It can't go against the diode, so it's only got this choice to go out that way. It's got to keep going in that direction. Goes out through the battery, comes back in through the electrical system, through the engine, through the chassis, to the engine, to the body frame, the casing of the alternator back here, and gets back to where it came from in that winding. So it gets back. So if we call them winding A, winding B, and winding C. So if B creates a current, for it to be a DC current, it has to get back to B. It'll use A or C to do that. Because remember, it's nearly instantaneous, this, because everything, remember, has atoms in it. So we have copper atoms from here, which is where it's starting from, one of these windings here in our stator. Remember, these are our stator windings here. In reality, that's what they look like in a diagram. But there are electrons all the way through, so I'm not pushing one out and waiting for them to go back. It's just a knock-on, like a domino effect. So once I hit one side, it pops back into me the other side almost immediately, which is why it has to use one of the other windings to get back to me. It's got to use an A or C. If B created it, it's got to use an A or C to get back to me. Because 2 will be outputting, 1 will be receiving, right? Okay, and why they have 3 windings in it? You'll see from your notes, it'll be quite slow to produce a wave. So what they tend to do is produce one wave from one winding, another wave from winding B, and another wave from winding C. So we have 3 windings here that are positive, so 0 upwards. And what it does is it uses probably the top ripple, is what they call of it, which is more or less a direct line. And that's what we want, DC current. Okay, I hope this video has been of use to you and helped you understand it, and I'll throw on a few questions to you. Any questions about this stuff, just give me a shout. Again, the testing part of it, mainly continuity for stator, continuity for rotor, diode test for the rectifier pack, and then the regulators. We are testing continuity for the brushes in here, and then the length of the brush and the condition of the brush. There's also visual stuff around it as well. I mean, with your rings up here, if those brushes aren't getting pushed out against it, what it'll happen fully against the slip ring, what will happen it will actually arc across here. If there's a small gap between one of the brushes and one of these slip rings, it'll arc across and cause a spark, more or less, like a spark plug. Signs that that's happening is you will get a blue tinge from the slip ring where it's happening. And if it's left and there's nothing is done about it for a period of time, it'll start to eat into that slip ring and cause big cracks in the actual copper of it because the heat gets so huge from the arc. So they're visuals that something is going wrong with the rectifier pack or brush pack. All right, okay. Hope this video is of use to you, and give me a shout if you need anything else. Thanks. Bye. Bye.